By the end of this video, we'll know how to convert the comparison of two Poissons into a binomial distribution. Let's get started. You are given the following information regarding two portfolios of ABC Insurance Company. Claims in Portfolio 1 occur according to a Poisson process with a rate of 4 per year. Claims in Portfolio 2 occur according to a Poisson process with rate of 2 per year. The two Poisson processes are independent. Calculate the probability that 3 claims occur in Portfolio 1 before 3 claims occur in Portfolio 2. The first thing that we need to know for this problem is something that I would like to first say what you should memorize and have on your formula sheet to memorize at least for the exam, and then we'll step into actually how to derive it. So very specifically for this type of problem, if you have two Poissons, you know an event occurred from one of the two Poissons. What's the probability that it came from, let's say, Portfolio A? We would say that's lambda A divided by lambda A plus lambda B. So this is just something, we're going to derive it below, but I would recommend just writing this down. I think it showed up in 2 or 3 of the past 4 exams. So it's worth memorizing just as is, but we'll step into how to actually derive that. So let's say you didn't actually know this was the case, and we needed to derive it on the fly. The way we would do that is first by saying, okay, for this specific case where we're only considering one claim occurred. So one claim occurred, which portfolio did it come from? There's only 2 possibilities. It either came from A or it came from B. First off, know that they're independent, so we can take this AND statement specified by the comma and just break it up into the 2 components. And then we also know what the PMF is of a Poisson distribution. So now we're just filling that out. So for example, this probability A equals 1 is just lambda A to the power of 1 times e to the negative lambda A, all divided by 1 factorial, since that's the number of claims we're interested in. And then we multiply that by the probability that B equals 0. So that exponent becomes 0 and this factorial becomes 0. And all of that works out to be lambda A times e to the negative lambda sub A times e to the negative lambda sub B. And then if we did the exact same thing for the other possible case, where Portfolio A doesn't have a claim but Portfolio B does, we get the same thing but with the A's and the B's switched. So these are the only 2 ways that exactly one claim can occur. So now going back to what we're considering, which is a claim occurred, what's the probability it came from A, right? That's what we're interested in. So we want to know what's the probability that a claim occurred from A out of the total domain of possibilities, so that either a claim came from A or a claim came from B. And so now we're just plugging in the values we prepped earlier. So in the numerator here we have the probability a claim came from A given exactly one claim came, and then we divide that by the other 2 possibilities. So that's the same thing as what was in the numerator, plus the probability that 1 claim came from B and 0 claims came from A. So that's how we have this really busy looking fraction here. And what we see is we have a common factor we can pull out. So in both the numerator and the denominator, we have this e to the negative lambda A and e to the negative lambda B. So we can pull that out of both, and those just become 1 and go away. All we're left with is that lambda sub A divided by lambda sub A plus lambda sub B. So we know that if we know one event occurred, and it only could have come from group A or group B, both of which are Poisson distributed, the probability is the following. So again, this is something just worth memorizing, writing down, making sure you know it for the exam, but this is just how you'd go about deriving that. The second thing to know, which honestly you don't if you know how to use your calculator, is just how to calculate and choose K. So I have the formula here, but you will have TI 30 built in because we're taking this exam during a pandemic, or if this, if you're watching this video a few years in the future and you're taking the exam in person, if you have a TI 30, you should be able to just plug in and choose K directly into your calculator if you have that calculator. But just thought I'd include that just in case. So now we can jump into the problem itself. So we know that for our two portfolios, we have the corresponding lambdas of 4 and 2. So scrolling back up, we see there's a rate of 4 per year for portfolio 1 and 2 per year for portfolio 2. So dividing those lambdas, we get that if a claim occurred and we don't know which portfolio it came from, there is a 2/3 chance it came from portfolio 1. So with that really sounds like a binomial distribution, right? It's like there was a coin flip and we know the probability of heads is 2/3. That really simplifies the problem now. So now that we know that corresponding binomial distribution probability, we can then try to summarize this question. So we know that what we're interested in is, let's see, the probability that 3 claims occur in portfolio 1 before 3 claims occur in portfolio 2. So that's kind of a weird way of asking it. So we're just going to rephrase it into something that is going to simplify the math. So instead of 3 occur in 1 before 3 occur in 2, we're going to say, of the first 5 claims, what's the probability that 3, 4, or 5 of them came from portfolio 1? And the reason we're going to say it like this is, 1, that's just 3 straightforward calculations we're going to be able to make, assuming the binomial distribution. And then also they implicitly fully encapsulate what the question is asking. So if 5 claims occur and 3 of them are from portfolio 1, obviously portfolio 1 had its 3rd claim first. Likewise, if there are 5 claims and 4 of them came from portfolio 1, same thing. And then furthermore with 5, if all 5 of them came from portfolio 1, obviously 3 came from portfolio 1 before portfolio 2. And this is a sufficient set because, of 5 claims, if 2 of them came from portfolio 1, we know that therefore 3 occurred from portfolio 2, and that doesn't fit in our set of interest. So going into the calculations, these are the 3 possibilities. And again, we've determined that the probability a given claim came from portfolio 1 is 2/3. And so now we just got to calculate these out. So an event came from portfolio 1 to the power of 3. So, 3 from portfolio 1, and then 1/3 to the power of 2, because 2 came from portfolio 2. But that can happen in multiple orders, right? So just because it's simpler, let's actually go to the middle one. So 5. So if we only had one event came from portfolio 2, the first claim came from portfolio 2, or the second claim did, or the 3rd, 4th, or 5th. So even though, 2/3 to the power of 4 times 1/3 is that probability that exactly one claim came from portfolio 2, there are 5 different ways that can occur. And that's why you have to multiply it by 5. And that's what this 5 choose 4 is. It's specifying the number of different ways you could order 4 claims occurring from portfolio 1 and 1 claim coming from portfolio 2. And so that's what this 5 choose n is doing in the front. So we have 5 choose 3, and that ends up being 10 different ways of ordering the event where there are 3 claims from 1 and 2 claims from portfolio 2. And then over here, 5 choose 5, there's only one way where all 5 claims could have come from portfolio 1. So now, with this mess of an equation here that we have, plugging all that into your calculator, you end up getting 0.7897. Scrolling up, we see that falls in the range of E. So E is our final answer. As always, I just want to say I really appreciate you taking the time to watch these videos. If you find them helpful, please consider subscribing, liking, or commenting below. Thanks. Have a good one.